Hi guys, thank you for coming back for another problem on how to solve a rational inequality by using test intervals. Since this is not our first rodeo, I think that's the saying, we're going to go straight to the problem, okay? So the directions read, use test intervals to solve the rational inequality, and then write the solution set in interval notation. So to solve a rational inequality, remember step 1, fix it so there's 0 on one side and a single fraction on the other. So let's do this. With your permission, let's subtract 4 from both sides. Okay, so fix it so there's 0 on one side and a single fraction on the other. Do what you gotta do. Okay. Did I write this problem right? I hope I did. Okay, so we got 0 on one side. Now we gotta work on having a single fraction on the other side. The popular mistake that students do is to wipe out the fractions. I feel you, because I hate fractions too. But again, when it comes to solving rational inequalities, we gotta face our fears and keep that fraction. Okay, so if you wipe out the fraction, that's it. You're gonna get a different answer. So let's go ahead and find the LCD. Because there's only one denominator, then that one denominator is that LCD. So the LCD is given by x plus 1. I was going to squeeze it in, but we're going to write this over. Okay, so we have 2x minus 3 over x plus 1. And when we're at it, we're going to write 4 as a fraction, namely 4 over 1. Okay, so minus 4 over 1. To make that 1 look like that common denominator, we're going to multiply top and bottom by x plus 1. Let's have our good notation. So we're going to have to wrap up that x plus 1. And we'll bring down the rest of the problem. So now the question is, are the denominators now the same? They sure are. We got an x plus 1 here, x plus 1 here. So let's go ahead and do this. So to subtract two rational expressions that have the same denominator, we're going to go ahead, subtract the numerators, and then write the difference over the common denominator. So let's do this. First numerator reads 2x minus 3. Operation is minus, and we're going to subtract from it the second numerator, namely 4 times x plus 1, and then we're going to write that difference over the common denominator of x plus 1. Okay, let's take our time. I mean, it just takes a silly mistake to for it to go downhill. So when we take our time and we distribute the negative 4, product of negative 4 and x is negative 4x, and the next product will give us negative 4. And that's all over x plus 1. Okay, let's take our time and combine like terms. When we combine the variable terms, 2x minus 4x will give us negative 2x. And the constant terms, negative 3 minus 4 will give us, what am I, negative 7. And that's all over x plus 1. Okay, so goal number 1 complete. Okay, goal number 1, fix it so we have 0 on one side and a single fraction on the other. Goal number 2, or step number 2, find all zeros. Find all zeros. Okay, because we have a rational inequality, the zeros are given by zeros of the numerator and zeros of the denominator. Okay, so we want to know what makes the numerator equal to 0. So let me go ahead and speak to myself. What makes the numerator a 0? If we want to know what makes the numerator a 0, we got to take that numerator and set that equal to 0. Okay, fantastic. So to isolate the variable term, let's go ahead and add 7 to both sides, and when we do, that will give us negative 2x equals 7. To finish it off, to get rid of the times negative 2, let's go ahead and divide both sides by negative 2, and that will give us any equivalent form of x equals negative 7/2. You can leave the improper fraction, you can write it as a mixed number, but I'm going to go with what students want, and they usually want a decimals. For me, I usually keep it as a improper fraction. Sometimes I get excited and I'll do it as a mixed number. So we know what makes the numerator a 0, but we want to find all zeros. So now we want to know what makes the denominator a 0. But before I do, I forgot to put my other love note. I want to know, is negative 3.5 a solution of the inequality? So like, am I going to put an open or a closed circle? So that open or closed circle question is dictated by the inequality symbol. If the inequality symbol has what I call the equal to part, then that endpoint or that 0 is part of the solution. If the inequality symbol doesn't have that equal to part, then that 0 is not part of the solution. So in this case, no equal to part. So we're going to do an open circle. Okay, so 1 0 down, one more 0 to go. So now I want to know what makes the denominator equal to 0. So let me go ahead, speak to myself. What makes the denominator a 0? And in this case, no matter what that inequality states, the denominator can't equal 0. So denominator can't equal 0. So must use open circle. Okay, so for this problem, it may not seem like a big deal why I highlight this, but if this was and is greater than or equal to, we will still use an open circle for the denominator. Why? Because the denominator can't equal 0, because the division by 0 is not defined. Okay, so let's do this. So I want to know what makes the denominator a 0. Okay, so we have x plus 1 equal to 0. After we subtract 1 from both sides, that will give us x equals -1. And remember our love note, the denominator can't equal 0, so we have to use an open circle no matter what. I hope you watched the other video, the one before this one. If not, you're going to have technical difficulties. Okay, let's do this. So how do we solve a rational inequality? So step number 1, fix it so you have 0 on one side and a single fraction on the other. Step number 2, find all the zeros. Find zeros at the top, find zeros at the bottom. Step number whatever number I'm at, use the zeros to split the number line into test intervals. So we're going to go ahead, bust out a line. It's not quite a number line yet until we highlight our numbers. So the zeros are -3.5 and -1. -3.5 is smaller, so that should appear first. -1 is larger, so that should appear thereafter. In terms of open and closed circles, we have open circle at -3.5. We have open circle at -1. Okay, so go ahead, finish writing your number line. I gotta copy this over. Give me a sec. Okay guys, I promise it didn't move on without you. I just had a copy over the number line. Okay, so to recap, how do we solve a rational inequality? I know I feel like a broken record, but I'm hoping that it will you will get it. Step number 1, set the put 0 on one side and a single fraction on the other. Step number 2, find all zeros. Find zeros at the top, find zeros on the bottom, and then use these zeros to split the number line into test intervals. So I copied it over. Okay, we have 2 zeros, which will split the number line into 3 test intervals. Let's go ahead and do that. 1, 2, 3. Okay, and if you love the grader, which I hope you do, please label the intervals 1, 2, and 3. And let's go ahead, test these intervals in order, starting with test interval number 1. Test interval number 1 is going to be all the numbers under -3.5. We cannot read each other's minds, so I'm not quite sure which test value you're going to use, but I would appreciate it if you put x equals and then tell me what is your test value. Okay, so with your permission, I'm going to test out -4, but if you're like, no, I'm going to test out 98 and negative, go for it. I just need to see x equals and your test value. I need to know, where are you testing this? Like, which inequality are you using? Are you going to use that original one? Are you going to use that revised one, the one that's being compared to 0? To me, I use whichever one looks nicer. Okay, usually, like, I'm a big fan of comparing to 0, but in this case, I think the original one, actually, you know what? They're both as ugly. They're both pretty ugly. I think I'll use the top one because it has one less negative. Yeah, that's the reason why. Okay, but you can use either one. Okay, so let's go ahead, write it down, so that way the grader know where these numbers are coming from. Okay, so we're going to use that original inequality. 2x minus 3 over x plus 1 is greater than 4. So let's see if our test value, whichever one you picked in that interval, is a solution. So we have 2 times x, which is -4, plus 3 all over x, which is -4 plus 1, and I need to know, is that really greater than 4? Okay, let me go ahead, zoom in. Okay, product of 2 and -4 is -8. And sum of -4 and 1 is -3. Sum of -8 and 3, where am I, is -5. And quotient of 5 and 3 is just 5/3. So I would love to say like, oh, is 5/3 greater than 4? I would love to say yes or no right away, but with tired eyes, I forget my own name. So I'm going to write this as an improper fraction, or we can use decimal equivalent. So I think this is like 1 2/3. So I'm going to say this is about 1.6. Something that I want to point out is this. I'm not really rounding, I'm just chopping it off or truncating it. If I was rounding to 1 decimal place, that should be 1.7, okay? Well, we have 5/3, okay, which is 1 2/3, or about 1.6 if we just like chop it, okay? We're not rounding, okay? The reason why I'm just chopping it because it's easier for me to see the decimal than the improper fraction. Okay, so now with confidence, let me just put about to remind me that I chopped it off. So I want to know, is 1.6 greater than 4? And the answer is no. Okay, 1.6 is not greater than 4. So check it out. Because our test value didn't check out, that means that none of the numbers in this interval are going to be a solution. So let's go ahead, cross it out for dramatic effect. Okay. Now, if that surprises you that I crossed it out, I'm crying because that means you didn't watch my other videos. Okay, so 1 interval down, 2 more to go. Let's go ahead, put number 2, because we want the grader to know what you're going to do next. Okay, and let's go ahead, put x equals, and then we'll write down what we're testing. You can test out any number of your liking. Just make sure it's in this interval. You can pick decimals, but love yourself. Let's pick an integer. We're going to go ahead, let's go ahead and use -2. You can pick whatever you want. And we're going to go ahead and use that same inequality. The only thing that I ask is, no matter where you plug it into, please write it at least once. Okay, and then I'll assume that you're going to keep using that same one. Okay, so we have, I'm trying to zoom in. Okay, so we have, where am I, 2 times x, which is -2 minus 3 over x, which is -2 plus 1 is greater than 4. Okay, I'm really running out of space. I want to do some mental math. Product of 2 and -2 is -4, and -4 minus 3 is -7. -2 plus 1 is -1. Quotient of -7 and -1 is 7. So the question that I want to ask myself is this: is 7 greater than 4? And the answer is yes, 7 is greater than 4. So check it out. Since our test value is a solution, that means that all the numbers in this interval is also going to be a solution. So let's go ahead, graph them. Okay, let me go ahead, scroll up. Cool, so we have 2 intervals tested, 1 more to go. Our third and final test interval, we want to test out the interval where the numbers are greater than -1. So again, you can test out any number of your liking. Just make sure it's in this interval. Okay, I'm going to go ahead, test out 0. You're like, nah, I'll test out 1,000,000. You know what? It's your grade. Do what you got to do. We're going to go ahead, test out 0. So we have test interval number 3. X equals 0. So again, oh sorry, I need to see the interval number, the test value, and then do your math. Okay, so you're gonna have to trust me on this. Okay, the inequality that we are using reads 2 times x, so it'll be 2 times 0 minus 3 all over x plus 1. X is 0 plus 1, and that should be great. Well, the inequality reads is greater than 4. Okay, so these numbers didn't come out of thin air. Again, it comes from the inequality. It's just I don't have the space to project it without zooming out. I'm running out of space, so let's go ahead, bust out the mental math. I'm just using my calculator. Okay, 2 times 0 is 0, and that will leave us with -3 over 1. Quotient of -3 and 1 is -3. So the question I want to ask myself is this: is -3 greater than 4? That's a lie. -3 is not bigger. Okay, so it doesn't check out. So the moral of the story is this: since our test value, no matter which one you pick, since our test value is not a solution, that means that none of the numbers in that interval are a solution. So I'm going to cross it off for dramatic effect. Okay. So question is, what is the solution set? It's just that interval. Okay, so in English, the solution set is like all the numbers that are between negative 3.5 and negative 1. But we gotta impress, our neighbors. So we have to write the answer in interval notation. So in interval notation, the solution set is given by the set of all real numbers in the interval from negative 3.5 to negative 1, where both endpoints are excluded. Okay, you're gonna have to trust me on it. Okay, so the solution set is given by, I don't know why I put answer. Sometimes I put answer, sometimes I don't. Okay, just box it. So it's the interval from negative 3.5 to negative 1, where both endpoints are excluded. Where did this interval come from? It came from the graph. Okay, that's why I love graphing the solution set, so that way I can feel more at ease. Bear in mind, you can the book, I believe they leave it as an improper fraction because I love fractions. I don't really care, just as long as you give me exact answers. Okay guys, that's my time. Thanks.